Hi there. This video has been in the works for a little while. It was pointed out to me a few weeks ago that my video about using EPROMs as combinational logic was almost silent. It wasn't recorded that way for some reason. It must have messed up in the YouTube system, and fortunately I can't find the original files to re-upload it. So I was going to re-record it or dub it over or something, but I've had further thoughts and wanted to add to the whole thing. That's why this video now is called using ROMs as combinational logic rather than EPROMs, because frankly you can use FlashROMs or any other parallel type ROM to do it. It all should work identical theoretically. Difference between FlashROMs and EPROMs is just the way the data is programmed into it and stored. As long as you can directly address in parallel and get the data out in parallel, then there should be no reason you'd be able to use any kind of ROM, or any kind of ROM or RAM. Well, obviously RAM, but it wouldn't be good because you'd lose your data as soon as you turn the power. So what I've done is I still haven't finished setting up my lab. It's been a busy Christmas, so I've actually taken the example footage from the original video and I'm going to be dubbing over it. It's only a short bit. But yeah, anyway, basically the idea, well, it wasn't my idea. I found the information in a book I read when I was a teenager. It's a book about the Z80. I can't find it. I may still have the book. I don't know. But it was about the Z80 processor, and there was a section on 7-segment displays. And it said if you cannot find a 7-segment display decoder, or you want to add custom segment patterns, then you can use an EPROM and just predetermine all the pattern in there. And when I was doing my Z80 project, I got to thinking, I had trouble getting these programmable logic chips working. But I actually got some Atmel ones that actually do work, but that's a different matter. And I thought, if you can predetermine the output for the logic, then you can use an EPROM. You just have to account for all the inputs, that's all. And it works perfectly. And I have I've proven this in the video footage I'm going to be showing you. But I don't see any reason why this cannot be translated to a FlashROM. I'm so confident I haven't actually hooked it up and tried it, but there's no reason why it shouldn't. But I will eventually do that and post a video about that once I get this all crap set up. But anyway, so here's the test circuit that we're using. If that focuses correctly. Just your standard your 5-volt input pulled down, so the switch is 100. The device is powered by 5 volts, and there's an LED resistor and a transistor to act as a driver, because I'm not 100% sure if the EPROM will drive an LED without any trouble, but that's there just in case. Now the device in the middle is the ROM, whichever type of ROM you fancy using. This only accounts for one input and one output, but obviously multiple, so you can use. Now so the basic idea is you each data address output line you assign it a Boolean equation to it, and and the inputs would be the address pins. Of course, you can reuse the address pins for different Boolean equations for the different data pins, but what you have to do is you have to create the truth table for the for that data pin, and then you have to basically combine it with the entire address range of the ROM that you're using. So it will repeat several times going down. But if you tie all the unused inputs to ground, then you only have to do the address space that's taken up by the pins you're using. Now, that will account for 1 bit on the data line of those addresses based on the inputs. Then what you do is you do your Boolean equation for each of your data lines that you want to use, up to 8, unless you have a 16-bit ROM, which should work fine. And then you have to combine them together, so it then makes up the data pattern that goes into the ROM. And so I'll show these on the screen. So the first one, basically my first example, I have written a small paper document. Now I'll post a link to that. Sorry, I'll post a link to that. That's on my website, and these examples are from that. So the first example would be to creating an AND gate. So what we do is we bring up the truth table here, and then you convert that into, so use the equation, convert it into the truth table, and then you convert that into the binary mapping, which is here. And basically you can see here I've done up to address 1101. You can see it repeats as it goes down. Basically you'll be doing this all the way down based on how many address pins are used. And then my second example, I will show you the an OR gate's Boolean expression and the truth table. So I'll put that right here, and then that gets converted into, well, that truth table then gets overlaid on top of the existing truth table, which I'll put right here. And as you can see, the original gate's in green, and the new gate added is in orange. This one's slightly longer because I wanted to show you the overlapping. Now, if you were to use only the 4 input pins, as here, all the other address pins can all be tied to ground, and then you don't have to worry about programming beyond that, because it'll never get to that. And but yeah, that's what you can do. Now, that is how you do it by hand. I have written a small program in Delphi that you can basically put your Boolean expression in. I haven't fully tested it, but you'll find a link to it on my website as well. It's in its early stages, this program, so it may have bugs in it, but it basically creates the binary file that can be burnt into the ROM, and as far as I'm aware, it works okay. So but yeah, okay, so what I'll do is I'll I'll show you the example. Basically it's using an AND gate and an OR gate, same as what was shown in these examples that I put on the text. Now, But the thing is, the second what was it? The outputs, I actually have them labeled the wrong way around on here. Crazy enough, but basically the AND output, I believe, is at the top, at the bottom. So what we'll do is I'll run the program. I'll show that video here, and then basically the input A, B, C, and D is on the left, and the output's on the right. So if you press A or B, it does nothing because it's an AND gate. So if I press both, the LED lights up. And C and D are the OR gate, so any one of those pressed will light up, and also pressing both of them. And that's basically how it works. It's fairly simple, but yeah, it's an okay concept. Dave Jones from the EEV blog, he actually created a PLC system based on this. I'll leave a link in the description below to his the magazine page or whatever he did. See, that's him using sequential logic. It's a bit more complicated to do, but he's shown that you can do it. But I'm only using combinational logic here. But yeah, but that's it. It's a good project he made. You should check that out. And so yeah, this is basically the concept that I described here, and hopefully someone will find it useful. So yeah, so that's it for this video, and thanks for watching, and I'll see you again soon. Goodbye.